Okay, so on this example, we have a function x to the 7x, and they want us to find the derivative. And they say that we should do it using a logarithmic differentiation. Now, why is that? Let me first, really quickly, we've got a lot of work, I don't want to use too much time, show you why. We know the rule, like if you just had x to the 7th, not 7x, but just 7, we know how to take the derivative of that. Just bring the 7 down, 7x to the 6 piece k. Or if you just had a number like whatever, 10 to the 7x. We actually know how to take the root of that. It's like e to the x, except you just do like that. You keep the same, then the adjustment. You might be a little rusty on that. Adjustment ln10, and then chain rule also would tell you derivative inside be 7. So it'd be complex, but we could do it. But what we can't do is we can't do x's in the base and in the power. You see the problem? We don't have a rule for that. Right? We have a rule when x is in the base only with numbers in the power. That's easy. We'll just bring it down, subtract 1. We have a rule actually that's harder when you just have numbers in the base, no x's, and x is only in the power zone. It's actually it's like e to the x. That's what e to the x is. It's called exponential. You basically do nothing at first, keeps the same, but then the adjustment, because it's not the perfect number e, so you go ln the base 10, and then chain rule, the inside's not simple x, so times 7. So it's complex. We can do it though. But we don't have a rule for x's in the base and in the power. We don't have a rule for that. So what are we going to do? That's why we got to do something new called logarithmic differentiation. So what do? Step number one, you ln of both sides. You take the ln of both sides. You come and you go ln of the left side and ln of the right side. And then step number two, you use the properties, the log properties. What are the log properties? So this is two. So log property number one says that the log of x times y is the log of x. What's the log of y? Property number two says the log, remember these pre-calc, of x divided by y is log of x minus log of y. And property three says the log of x to the power. You can actually bring the power down to the front, and it's power times log of x, like that. So we got to use those properties. So really the only one we're going to use is this one. That's just going to come down. All that writing, we're just going to use that one. Okay, so it's ln of f of x equals, and that 7x comes to the front times ln of, and now just x. So we just use that third property. Now, why is that so great? Well, because now it's not x's in the base and the power anymore. It's just x's multiplied together, and we can do that. It's called the product rule. So you see, we've transformed it into something we can do the derivative on, and that's what we're going to do now in step three. So step three is you take the derivative. Get some more room here. We're going to take the derivative of both sides. So I'm gonna go, oh, okay. So I'm gonna take the derivative of both sides. So I'm going to take the derivative of this side and take the derivative of that side. So, okay, what happens? Well, on the left side, what always happens when we do the derivative of that, so we have the ln of the f of x. Remember the derivative rules for natural log? It's 1 over the argument, right? Whatever's plugged in, natural log. But then because the inside is not a simplex, you're going to go times the derivative of the argument because the chain rule. Okay, and then you can simplify that. This is really over 1, so it'll go to the top. So it's going to be f prime of x over f of x. That's the derivative on the left side. It'll become let's go do it. It's going to become f. Well, here I'll make it a new color for clarity. It's going to become f prime of x over f of x. Do you see that again? Because remember, the derivative of natural log is 1 over the argument, but because the inside's not a simple x, it's times the derivative of the inside derivative of f of x is f prime of x. That's over 1 goes to the top. It's f prime of x over regular f of x. Okay, now how do you take the derivative on the right side? Now that I look at that right side, it's a product rule. Do you see that? Right? Because this and this are two functions of x. So multiply. So product rule. So first guy goes, what's the derivative of 7x? Just 7 times the second guy, just no change, plus the first guy, no change, times the derivative of the second guy. What's the derivative of the second guy? Here's the derivative of this one. This is the derivative of that one. It's a 1 over the argument, 1 over x. So that makes sense. I just did the product rule, which means they took turns. So the 7x went first, his derivative was 7, the second one just sat there. Then the first one sits there, and the derivative of the second one, natural log x, is 1 over x. We can clean that a slight bit, not much. Basically, these guys can cancel. That's pretty much it. So we have f prime of x over f of x equals 7 natural log of x plus just 7, because these x's canceled there. Now, are we done? Is that you think, well, that's the answer. Not quite. F prime is not alone yet. Remember, we're trying to find F prime. If this is F prime over F. We want F prime alone. So our last step, step number 4, multiply both sides by F of X. So I got to come in here and go, okay. So F of X over 1, so it cancels, and then the whole right side also by F of X. Excuse me. So I just multiplied both sides by f of x to get this to cancel out, so f prime will be alone. So then f prime of x equals, well, all of f of x. What is f of x? That's the original function right here, x to the 7x. So that's x to the 7x, and then 7 natural log of x plus 7. And so there we go. We took the derivative. Do we get it? I'm hoping. Oh, they factored out the 7. It's fine. The way we have it is fine. Yep. Last step, now they want us to plug in a 1. So let's do that. So let's just put a 1 in. So we're going to plug in 1 here, 1 here, 1 here. That should be easy. 1 to the 7 times 1. 7 ln 1 plus 7. Well, 1 to the 7th power, that means 1 times 1 times 1 times 1, 1 times 1 times 1, right? This is 1 to the 7th power. That's just 1. And ln of 1, you check on your calculator 0. So this is 1 times 7 times 0 plus 7, which is 1 times 7, which is 7. And that's what they got, 7. Yep. And so there we go.